Okay. So welcome to the webinar. Today's webinar is going to be on timing control in Experiment Builder. And I made a PowerPoint to kind of organize the webinar for us, and we can jump back and forth between that and some kind of hands-on Experiment Builder training. So I'll be jumping back and forth between some Experiment Builder projects and this PowerPoint, and I will post this PowerPoint and the projects to the same forum post that has the webinar on it. So you can use this as a reference later. So today's topic is going to be timing control in Experiment Builder, and I mean, I'm sure as you all know, timing is usually critically important in psychology experiments, and so it is critically important that people who want to create psychology or cognitive neuroscience experiments using Experiment Builder know how to properly control timing. So that's the topic of today's webinar, and in terms of an agenda, we can start by just discussing some monitor and audio considerations. So you can only really kind of do what your hardware will allow you to do, and so we need to talk about some of the considerations and limitations of this hardware. Then we can go into basic timing control, just like how do you present a display stimulus, for, like a visual stimulus for a certain amount of time, for example. Then we can talk about how you can log the times of these experimental events to the data file. And we can also talk about how you can log the times of the experimental events to variables. So there's a little bit of a difference between these two things. The short version of the story is that logging the event times to the EDF is kind of a mandatory thing that everybody should do, so that later during data analysis you can properly set what we call an interest period when you're doing your data analysis in Data Viewer or whatever software you're using. And so that's kind of like your main stimulus marker, your main marker of when these events happen. But then optionally, you can also log the times of your events to variables. And this will just give you kind of like, for this trial, the time of the stimulus display was 10,523, and the time of the next stimulus display was 15,523, for example, something like that. So that's another way you can keep track of the timing of things, but it's a little bit less useful. It's more just kind of like a record-keeping thing, but we'll talk about that. Then we'll talk about how you can kind of link the start of timer triggers in Experiment Builder to particular events. And one of the kind of most common uses of this type of thing is like in a visual world paradigm. Maybe you have an audio file that's playing and you want to mark the times of certain critical words that are spoken in that audio file in the data file. And that can be useful in data analysis too. So we'll talk about how to do that. And I just made like a little simple example that shows how to do that. Then we're also going to talk about some things that are kind of idiosyncrasies of Experiment Builder, but that are important to be aware of if you're trying to control the timing. So the first thing is we'll talk about a prepare sequence action. It's kind of this little bit of a mysterious action in Experiment Builder, and we'll try to demystify it. And then we'll also talk about the is real-time property of sequences in Experiment Builder. And then finally, we'll talk about a little bit more of an advanced thing that kind of ties all these things together, and that is like how to control the intertrial interval in Experiment Builder. And so this can be useful. Sometimes people need to control the intertrial interval just for the sake of the experimental design, but particularly in cases where you're trying to integrate with third-party devices, like maybe an MRI, for example, you might want the intertrial interval to be fixed at some amount, and that way you can kind of make sure that your two devices stay in sync throughout the experiment. So we'll just talk about like how you can control that intertrial interval. And as usual in our webinars, like if you have any questions along the way, like feel free to you know, use the hand raise icon or just start a chat or something. So please feel free to interrupt. So let's just jump right in and start by talking about some monitor considerations. So you can only like draw on your monitor at certain times, and the times when you can draw on that monitor are determined by some kind of critical properties of the monitor. And I wanted to just kind of clarify what these two properties called refresh rate and response time are when it comes to monitors. So the refresh rate is the number of times per second that a monitor can or will update the contents of the screen. And this is basically saying like how many times a second can the monitor be updated. And let me just show you, like you can actually set this through your operating system usually. So what I'm going to do is just show you how to set it in Windows 7 because that's what I'm running here. So if I right click and then I go to screen resolution, this will bring up kind of like the properties of the monitor. And you can see you can change the resolution. So the resolution is like how many pixels wide and tall is the monitor's display, and you can change that to different values. But for a given resolution, you can also set a refresh rate, and you can do so by going into advanced settings and then go to monitor, and you can see screen refresh rate, and you can see this one can go up to 144 Hertz, but it has these other options too. Almost all, or at least all the LCD monitors I've ever seen can do 60 Hertz, but sometimes for certain types of experimental paradigms you might need the monitor to update more often than that. So an example of this is like a boundary crossing experiment. If you're doing like a reading experiment and when the person's eyes cross a certain boundary in the text, then the screen can change. Like if you want the screen to change based on where their eye position is, then you want that to happen super fast, or as fast as possible at least. And so in these types of cases you might want to get a monitor that can refresh at a very fast rate. So this is like how many times per second the monitor can be updated. And I'll show you in just a second how, like, actually I'll show you right now. So if I open up an experiment builder project, and this is one of the examples we'll talk about later, if you go to the devices tab of the structure panel and then go to the display section, you can see this is where you can set the monitor's resolution and the refresh rate. And so right now, like if I run this project, when I run it, it'll change my monitor's resolution from its current value of 1920 by 1080 to 1024 by 768, and it'll set the refresh rate at 60 Hertz. And if your monitor can't do that refresh rate and resolution combination, then the experiment will crash. And if it can do that, then it'll temporarily change the resolution and refresh rate values to the settings that you have under the display section of the devices tab of the structure panel. And then when the experiment's done, it'll go back to your Windows settings that you were using before. So that's how you can kind of set your experiment's resolution and refresh rate. And if you're using a fast monitor like I am here, I might want to change it to 144, for example. But just to make it so that it can work on anybody's monitor, I'm going to put it at 60. Okay, so let's get back to the PowerPoint. If you were running at a refresh rate of 60 Hertz, then that means that the monitor can only update every 16.67 milliseconds. So the way I'm figuring that out is, like, if it's updating 60 times a second, then that means within 1 second, and a second consists of 1,000 milliseconds. If we divide that 1,000 milliseconds by our refresh rate, then that means within 1 second, we're going to have 60 refreshes, and the refreshes are going to be 16.67 milliseconds apart. And so to give another example, if we were at 100 Hertz, the refresh interval would be 10 milliseconds. And so this has some consequences for your experimental design, and just please note, this isn't like any kind of limitation of experiment builder. Like, this is literally just a limitation of what monitor hardware can do. So basically, let's say we're using a 60 Hertz refresh rate in our experiment. Then that means in our experiment, our timers should be set to be multiples of that refresh rate. And so anything that's a multiple of 1,000 is always going to be a multiple of the refresh rate, because if monitor can refresh 60 times a second, like 1,000 milliseconds is 1 second, and so we know that any interval of a second is going to always work out. But let's say, for example, I'm running at 60 hertz, and I set up like, I'm just going to kind of draw this out on the side here. I'm assuming y'all kind of know the basics of Experiment Builder, but if I draw a screen here and then put a timer and then put another display screen after it, and then I try to set this timer to 40 milliseconds, for example, that's not really going to work out because the monitor can only update at 16.67, 33, and 50 milliseconds. Like, those are the kind of like durations that are possible around 40 milliseconds. So that means when you actually run the experiment, instead of this screen and this screen being 40 milliseconds apart, they're either going to be 33 or 50 milliseconds apart. So that what I'm trying to illustrate is just that your choice of the timer durations should depend on the refresh rate that you're using here. Okay, so it looks like there's a question here, so I'm just going to try to answer that question. Yeah, if you can just type the question into the chat thing, we can address it once you get that going. But anyway, so that's a limitation of the timing of the monitor. The monitors, especially LCD monitors, also have this property that's called a response time. And this is kind of, and projectors too have this. So this is kind of critical thing to be aware of. So let's say your monitor is running at 60 hertz. Then that means 60 times a second, your computer is going to be sending a signal to your monitor saying, okay, let's update the screen. Okay, or at least it can do that 60 times a second. The response time is the difference between the time when the monitor receives that command to update and then the time when the screen actually changes or that update is actually like implemented. And so the way that we test that, like we test monitors to make sure that they are performing as advertised, because it's important for experiments that monitors perform well. And we just do that by putting a little photodiode up to the screen and then switching the screen like rapidly between black and white, for example. And the photodiode can tell us the time of each of these updates, and we can know the time when the command is sent to the monitor just through some kind of programming tricks, and we can compare the time when the screen actually changes to the time when the command is sent to the monitor, and that effectively is what is referred to as response time. And with the old style like cathode ray tube CRT monitors, that response time was basically negligible. So it's super fast, like way less than a millisecond. But with modern LCD and LED monitors, this response time can actually be kind of significant. So it can be like, we've seen monitors in the 20 to 30 millisecond range of response times, and I know some projectors are up to like 50 or maybe more in terms of response times. So we have identified, like SR Research has identified some monitors that perform well and perform as advertised, and we kind of maintain a list of that as a service to our users, just so that they can feel confident in the timing of their experiments. So if you're interested in like a list of those monitors, just send us an email to support@sr-research.com and we can send you a list. But anyways, those are important things to be aware of. In terms of audio, so audio is kind of a different beast. Experiment Builder can work on Mac and Windows computers. On Mac computers, the audio, just like the native audio of Mac, has excellent timing properties. So the delay from the time the command is sent to your sound hardware to like play the audio, compared to the time the audio actually like comes out of the speakers or headphones, it should be around like 2 milliseconds. On Windows computers, let me show you. If I open up an Experiment Builder project and then I go to the audio section of the devices tab of the structure panel, you can see, since I'm on Windows, I have these two options, DirectX and ASIO. If you set it, like, if you don't have an ASIO audio, like sound card, then you only have one choice, and that is to use DirectX. And if you're using DirectX and you play some audio, then the time when that command is sent to play the audio and the time when the audio comes out can be considerable. So, like, we've tested this using some special cables and special, like, specially programmed experiment builder projects, for example, to test this latency. And it's kind of unpredictable, unfortunately, and it depends on exactly what computer you're using. Oops, let me jump down to. So usually it's going to be in like the 30 to 50 millisecond range, if I remember correctly, but it can be higher than that. And so if timing is important for audio playback, then it is kind of critical that you use an ASIO sound card. And the Experiment Builder manual has a little section in installation, Windows PC system requirements, ASIO card installation, and I'm just going to quickly show you that. If I go Help, Contents, and then go to that little section that I mentioned, you can see there's a table, and that table lists all these different sound cards that are supported, and like each row is a different sound card, and the columns are the different operating systems. And like if I'm on 64-bit Windows 7 and I'm using, for example, ASUS Zonar DS, then I can click on this supported thing and I'll get instructions for how to install that audio hardware. And so once you have that installed properly, then you can go to your Experiment Builder project and set that audio driver to ASIO, and then you can feel comfortable with the timing properties of your experiment in terms of the audio stuff. Okay, so I just wanted to point out those timing considerations because they're kind of like, they're things to be aware of. They're not really related directly to Experiment Builder, but they're hardware considerations to be aware of. So now let's like shift gears and start talking about, like, let's say you got all the hardware set up how you want. Let's start talking about how you can like implement certain timing controls. So let's go back to our little slide. Oops. So in terms of like basic timing control in Experiment Builder, I just made a little screenshot here and put it in the PowerPoint. If I have a display screen action followed by a timer trigger and followed by another display screen action, then the properties of this timer trigger are shown over here on the left. One of the properties of that trigger is its duration. And so that's going to mean that whatever is kind of going to be presented by this display image 1 action is going to stay up for 5 seconds, and then the display image 2 action should be presented. And since 5,000 milliseconds is a multiple of really any refresh rate, or I should say a multiple of any refresh interval for any refresh rate, then since that is a kind of acceptable duration, then this screen should stay up for 5 seconds, and then the next screen should be presented. Okay, so that's just kind of the very most basic timing control in Experiment Builder. I think like let me just show you a rookie mistake in case maybe y'all have done that before, but a rookie mistake is to do something like this and then connect these two things. Like that's a big no-no. Like don't do that in Experiment Builder. Like basically, I'll say working as a technical support guy, like when I get a project that has something like this, I just immediately know, okay, so they must be new to Experiment Builder. But anyways, basically this is not really a good thing, because since there's no trigger in between these two display screen actions, the contents of this first one are just going to stay up for literally like one retrace, and then the next screen is going to be presented. So that's not really what you want to do usually. You want to separate these by some kind of trigger. So if I just want to like give you the basic example that I showed you in the PowerPoint, you could do something like this. Okay, and that's what we have. I'm in this example called Simple Timing Example. Let me save this. And at the very beginning of the experiment, it shows like some instructions, and I double-clicked on that to see that. And then after it shows those instructions, it waits for a keyboard, a timer, or a button press. and whichever one of these things happens first will take us down to the camera setup action, which will then change the screen to get us ready for setting up the camera and calibration. And so in this case, if we look at the timer trigger, it has a duration of 2 minutes, or 120,000 milliseconds, and so this should stay up for 2 minutes maximum. And if you press one of these things, a keyboard or button, then it should end that early. So that's kind of the basics of timing in Experiment Builder. So it's kind of simple, but once we get into some more complicated things, you can see there's more to it than that. Let me just mention too, like right now I have the duration type set to milliseconds. If we wanted to present the contents of a display screen for a certain number of refreshes, or frames as it's called here, it's the same thing as a refresh. If I wanted it to stay up for, let's say, 1 second, and I'm running at 60 hertz, and I can put 60 frames. And since we're at 60 hertz, then that means 60 refreshes, or 60 frames, should be 1 second. So basically 60 frames should be equivalent to 1,000 milliseconds, if that makes sense. So if you wanted to present something for 1 frame, for example, and you didn't want to have to worry about what your refresh rate was, you could change this to frames and then put 1 there, and that should be fine. Okay, so let me get back to the original value here. And so that's just kind of like basic timing control. Let's move on here to a critical kind of consideration in any Experiment Builder project is to log the time of certain experimental events to the EDF file. And if you've like watched the Experiment Builder video tutorials or seen other introductory webinars or something like that, you're going to know this is like one of the most critical things in Experiment Builder programming. I just wanted to re-emphasize it. Basically, all actions and triggers have a property called message, okay? And this message property, whatever you type in here, is going to be sent over the Ethernet connection between the display PC and the host PC. It's going to be sent from the display PC to the host PC to be inserted in the eye tracking data file at the time of execution of this display. So in other words, at the time when this is displayed, the simple version of the story is at the time that this is displayed, this message text is going to be sent over the Ethernet connection and marked in the data file to tell us when we're looking at the eye tracking data, like when did this stimulus appear to the participant. Okay, and the messages are super fast. You can test, there are lots of different ways to test it. A very simple way to test it is like make an Experiment Builder project and just send back-to-back messages, or make a Psych Toolbox from MATLAB example and just send back-to-back messages. Like, messages take way less than a millisecond to be sent from the display PC to the host PC. So basically, like if you're in need of like 1 millisecond timing precision from Experiment Builder, then the message timing is almost negligible, right? So it's sub-millisecond. But what I should point out, one thing here is Experiment Builder is a bit clever in some ways. So one of the things it will do is, like, Experiment Builder doesn't really want to be drawing to the screen and sending the message at the same time. So in an effort to kind of like optimize the use of the computer resources, Experiment Builder will actually check to see when the scheduled retrace that will update the screen with the contents of the display screen action, Experiment Builder will check to see when that scheduled retrace, or Experiment Builder will check to see when that retrace is scheduled to occur. And it will write the message to the EDF file in advance of the actual updating of the screen based on that display screen action. And when it sends that message, it will include a little offset value. And so that offset value is gonna basically be equal to the difference between the time when the message is sent and the time when the monitor is scheduled to actually update the screen. And so in this case, like, the contents of display image 1 are going to actually be presented 15 milliseconds after the time of the message. So the message is sent 15 milliseconds. In this little example, the message is sent. This is. Oops, sorry. Let me get back. This I should mention. This text down here is what the message is going to look like in the actual EDF file. If you convert it to like an ASC format and want to just look at the raw data file, you're going to see something like this in the data file. And the time, this first value here is the time of the message. And so what Experiment Builder is going to do is a little bit before this display screen action, it's going to send the message over, and it's going to calculate the difference between the current time and the time when that display screen is set to actually change the monitor, and it's going to put that difference as a little offset value right here. And so this offset value, when you open the EDF file in Data Viewer, this offset value will be subtracted from this timestamp so that Data Viewer can like properly reflect, like the time values in Data Viewer can properly reflect the times when these things actually occurred during the experiment. So if you look at the time of this display screen update in Data Viewer, it'll actually say 606084. And so I'm subtracting this -15 from this value, and it would say 606084. And that'll tell us the time when it actually updated. Okay, I just want to make sure that's clear. Like if you look at the raw data file, you'll see that the timestamps of display screen actions actually have this little offset, and just feel like comforted, I guess is maybe the right word. Feel comforted in the fact that if you open the file in Data Viewer, these offset values are already taken into account, and you don't have to do anything or think about it. Okay, I just want to, if you're looking at the raw data file, that's just kind of how Experiment Builder is working. Okay, and so these messages that we're sending to the EDF file are critical. And just to kind of like show you, if I open up a Data Viewer, just like open up a little example in Data Viewer, import data. I'll just import an example file quickly. Data Viewer, SR Research, Data Viewer, samples. Okay, I'm just importing a data file. And in Data Viewer, like maybe I have several display screen actions in my experiment, like we do. Like if I go into the recording sequence of our little simple timing example, we'll talk about this more in a second. You see we have a lot of different display screen actions here. So we have 4 of them. Maybe when I'm doing the data analysis, I only want to look at the eye movements for this section of each trial when this particular image was shown. So I only want to look at the data from the time of this display screen action, from the time of display image 1 to the time of display image 2. And so in Data Viewer, you can go up here to your little interest period manager and go edit, and then make a new interest period and go from one message, display image 1 to display image 2. And then you'll only be looking at the data from for the time of the trial when the first image is presented. Okay, so, and then you set your little interest period, and then when you say OK, you'll only be looking at the data for that period of the trial. If you want more information on that, you can see kind of the introduction to webinar to Data Viewer, but that's super important. Okay, looks like we might have another question. If you got a question, just chat at me. Oh, it says some static noise muffling my voice. No. Okay, are you still hearing that staticky? Are you still able to understand what I'm saying? Okay. If something happens and you can't understand what I say, just ask me and I'll try to clarify. But I guess we'll just have to live with the static because I can't really troubleshoot that right now. But my apologies for that staticky stuff. I tried to do some tests, but I guess I missed that. Okay. Anyways, so we can use these messages to set interest periods in data viewer and kind of focus in on certain parts of the trial. Sometimes people just want to have like a record, like the numerical time of certain display screen actions or certain sound actions, something like that. They want to have the timing of these things saved. So maybe they want to have a variable that says, okay, in this trial, display screen 1 happened at time 65,212. Display screen 2 happened at time 70,212, something like that. And so I'm going to show you another trick you can do. You don't have to do this type of thing, but it's a nice little thing that some people want to do just to be able to check, like do a quick check of the timing. I just wanted to show you. So like if we go back to this simple timing example, the structure of this experiment is very simple. It's like calibration here, do a trial loop. Within each of these trial loops, we're going to do some things before the trial starts, and then we're going to do some recording of eye movement data. And so the actual trial events are going to be inside this recording sequence. Again, you can check out the intro videos for more information about this. But within a trial sequence, I'll come back to this one here in a second. But basically, we're going to display one image, and this comes from one of the columns in our trial data source, image 1. So we're going to, if we look at the source file name, it's getting its the image to be displayed from image 1 column of our data source. So if I go back to the data source, you can see we have image 1 column. So we got a reference to that column from that image resource, and that's being displayed by this one. And then we're going to have, that's going to be up for 5 seconds. And then we're going to display a second image, and this, it looks the same here, but if you look at its source file name, you can see that it's referencing image 2 column, okay? And then that's going to stay up for 5 more seconds, and then we're just going to see the word question. And if we look at, since I'm using an ASIO sound card, when I turn on the ASIO, let me show you. Once I turn on ASIO as the audio driver under the audio section devices tab of the structure panel, that reveals, if I add like another display screen action, one of the properties of that display screen action will now be synchronize audio. And so that's what I've done for this. Let me delete that. That's what I've done for this display question node here. And you can see I've checked synchronize audio, and once I did, it brings up an extra property called sound file. And I made a reference to the data source column called sound file. And if we go and look at that, it's going to play this audio file that it's just me, I just recorded this morning, me saying something like, did you see a city or a dog in the first image of the trial, or something like that. And so it's just like some stupid little question asking whether they saw a city or a dog, and the idea is to press a slash if it was a dog, or Z if it were a city. Okay, and so that's the task here. So basically when this question screen appears, because I checked the property synchronize audio and then reference that audio file column, and I also like imported that audio file into my library manager under edit library manager. But when this question appears, we're going to hear the sound file at the same time, so they're going to be synchronized. If you wanted the sound file to start a little bit later, you could change this sound offset value, but I just left it at 0, meaning that the sound file should start playing at the time when this question screen appears. And we're going to come back to these little guys here, but basically these guys here are going to mark like the times of some critical words in the file. So I wanted to mark the time of the word city and the time of the word dog in the audio file, and so I'm using these timers to do that. We'll come back to that. And then this little guy is going to check to make sure that the audio file has stopped playing. Once the audio file is finished playing, we're going to just start waiting for a response, and you can see here they can press slash or Z, and then we can check whether they're correct or incorrect, and we can set these 3 behavioral data variables based on that. I'll come back to that in a second, and then we can blank the screen. And then, so that's kind of like the trial events, okay? I just wanted to give a quick summary of what happens in the experiment. Let's say we want to have stored in our data files the timing of these different events. And when I say stored in the data files, I don't mean just like markers with this message. What I mean instead is we will have variables called time image 1, time image 2, time audio onset, time blank. So these are variables that come from the other section of nodes up here that I've added. And these are just going to store like the numerical time values of these different experimental events. And just to kind of foreshadow, like those values cannot be used to set interest periods in the same way that we used messages to set interest periods, but they can be included in any of the data output reports that you create from Experiment Builder. I mean from Data Viewer. And so basically anytime you have a variable here in Experiment Builder and you have selected that as one of the variable EyeLink DV variables at the topmost level of your structure panel. So let me select all these and move them over to the right. Once you select those and move them over to the right, then that means whenever a trial ends, or in other words, whenever we exit our recording sequence, it's going to write the values of all those variables to the data file as kind of special like trial variable values. And then those variables will become columns that you can include in any of the data output files that you create. And so that way you could just have a numerical value of like, if we look here, time of image 1, time of image 2, time when the audio started playing, and time blank, if you set these variables correctly. And so what I'm doing here at the very end of the trial, after these events have happened, is I'm using an update attribute action, one of these guys, to set the value of these 4 variables, okay? And the way update attribute actions work is like you can click on the attribute value list and you can see on the left side of each of these rows I put a reference to the value property of a different one of these variables. And so just to show you how it works, I can click here, click on this little special button that we use all the time in Experiment Builder. Let me delete this and I'll just go from scratch. So if I want to set the value of the time image 1 variable, then I can select that time image 1 variable and double click on the value property. And so that means on the left side we are setting the value of this time image 1 variable, and on the right side we're specifying what we're setting it to. And so what I want, well, I'll just rebuild that. What I'm going to do here is set that to be equal to display image 1 time property. And so that means we're setting this variable to have a value equal to the time when that image was displayed. And since we're, like I kind of mentioned earlier, maybe we're only interested in precision at the millisecond level. Like if I didn't do what I'm about to do, then this time value would come out as like a number with a long decimal, and the decimal units would be like, I think, down to like the 10,000th of a millisecond, which is a little bit ridiculous. And so what I'm going to do here is like, I'm going to say equals int, which is going to turn it into an integer, and then I'm going to round. This is just a little like Python trickery. So what I'm doing here is like first I'm rounding what's inside this inner bracket here. I'm rounding the time of the display image 1 time. I'm rounding it kind of like to the nearest integer value, and then I'm actually like literally converting it to an integer type. And so that this, you don't have to do this if you don't want to, but this will basically round the time of that display screen actions execution to the nearest integer effectively. And so that way the value of our variable in the data file will be rounded off to the nearest integer, and the unit is milliseconds, so that should be fine. And then, so I'm doing that same type of thing for image 1 variable, image 2 variable, and time blank variable. Sorry, time image 1, time image 2, and time blank. So this first second and fourth lines, I'm just setting the time of these different display screen actions, okay? But then I'm also keeping track of the time when the audio onsets. And so on the right side of this equation, I'm basically doing the exact same thing as the other ones, but inside the innermost parentheses, I'm saying display question, not its time, because that's the time when the screen is displayed, but the play start time. That'll be the time when that audio file starts playing. And so this way I'll just have like 4 little extra variables in the data file that keep track of the times of these events. And again, this is just an optional thing. You don't have to do it, but it allows you like a quick way to check the timing of these events without having to like look at the times of the messages or something. And I kind of mentioned that we have that after the subject responds to the question, we're going to set the values of some behavioral variables. So I have a reaction time variable, a key press variable, and an accuracy variable. And if you're interested in how those things work, the easiest way to kind of check that is go to the support forums. Oops, let me just log in. Go to our support forums, sr-support.com. And under video tutorials, we have just kind of intro to Experiment Builder. You can check out, this is like discusses an Experiment Builder project. You can check out the behavioral data logging one, which kind of describes how to record the values of like reaction time and which key was pressed and whether they were correct or incorrect. And this is just using the same trick. Okay, so that's how we can log the times of these events in variables. Okay, and so that's what I was trying to illustrate here. And this little node is the one that does it. Then another trick. So let's go back. I kind of mentioned that we might want to mark the time when critical words are uttered in the audio file. So in the audio file, I think, like, as I mentioned, I think I said like did the first picture, or how did I word it? It was something like, did you see a dog or a city? I think, or did you see a city or a dog in the first picture? Something like that. Did you see a city or dog in the first picture? And I wanted to mark the time of city and mark the time of dog. I mean, this is kind of a dumb example, but like just in case I wanted to, like in the data analysis, if I wanted to know like where they were looking when they heard the word city or when they heard the word dog, then I could have that information by marking the time when those critical words are spoken. Okay, so the first thing I did to do this is I recorded an audio file, and I'm just going to open up that audio file in like a little audio editing software. So if I go to library audio, there's the audio file, and I'm just going to open this with like Audacity. Actually, I'll do it this way. Okay, this is a free editing sound audio. So what I did was like, this is the audio file. I just kind of like haunted. I don't know if you can hear that, but like when I play that, I think that's supposed to say this says city. That's the point of city, and then later on there's a point where dog is spoken. And so I just checked the time down here once I found the point where the critical word was spoken, and then I went into a data source and created 2 columns: critical word 1 time and critical word 2 time. So these critical times were the time from the onset of the audio until city, and then I think dog is here or something. And so I just found those times and then typed them in here. Okay, and what we did here, this is when the critical word is spoken. I used a couple timer triggers, and the timer trigger, you can see for its duration, is getting its value from a reference to that data source column crit word 1 time. And I mean, I just use the same audio file over and over, but you would have different like times for different audio files listed out here. But we're basically grabbing this time and using it in the graph here to simply send this message to the data file X amount of milliseconds into the audio file playing, into the playback of the audio file. And so the only point of these timers is just to mark in the data file the time when these critical word utterances occur. And so for this first one, it's going to send the message timer critical word at this time that comes from the data source value, and then after that, it's going to send another message timer critical word 2 to the audio file. But all right, for this one, I could have actually just left the start time at 0 because we want it to start kind of as soon as the audio file starts playing, and since the audio file is synchronized with this, basically if you have a start time of 0, this timer will start with its 0 point being the time of the previous action. And so in this case, the previous action was the onset of the audio file, so having 0 would be fine. But for this second one, if we had the default of 0 here, let me just delete these guys. If we had the default of 0 here, then this would start, instead of starting with this being the 0 point, this would be the 0 point. And when I wrote down the times, I didn't want to write down like how long it was from the first critical word until the second critical word. I still wanted to know how long it was from the beginning of the audio file to the second critical word, if that makes sense. So, because I didn't want to have to be subtracting these values or something like that. And so, like if I just click here, it'll tell me the time from the start of the audio file until this word. And so since I want the message for the critical word 2 to be sent X milliseconds from this audio onset, instead of using 0 here, which would start the timer when basically when the first word is spoken, which is not what we want, I want to start it at the beginning of the audio file. So what I'm going to do here is for the start time property of this second timer, click here, click on this little button, find our display question, and reference the play start time. And so that means this timer is going to fire this amount of time from the time when the audio file started playing. And so that way you can have like a lot of these different markers, and they can all be kind of have their timers linked to the time of the audio file playing. And I'm just going to go back to this one to be consistent and fix its little start time property. Okay, and so this way we can have little markers in the data file of these things, and then when we do our data analysis, if we want to set an interest period in data viewer, again using this little special tool up here, then we could, for example, look at eye movement starting at, let me just make sure that's the right message, timer critical word 1. Then we can set a like that, and maybe we wanted to go until the second word was spoken, and then we could do that as the end time message, and basically set our interest period based on that. In visual world experiments, a lot of times people want to look at eye movements from the onset of the critical word until some amount of time has elapsed. So in that case, you can change it to the IP end event to be a duration, and maybe go to like 2 seconds after that critical word is spoken. Okay, and if you wanted to like start 500 milliseconds before that critical word is spoken, you could do something like this, and then we would have an interest period that starts 500 milliseconds before the critical word was spoken, and it would go to 1500 milliseconds after that critical word is spoken. Okay, for a total of 2000 milliseconds. So that's how we can kind of use this little trick of linking our start time property to give us messages that can then be used to set interest periods. Okay, so that is like basically the little trick of linking or referencing the start of a timer to a particular event. Let me show you just one more little example of how we could do that. Let's say we want to present a stimulus, and the person needs to respond. And so they can respond, but we want, if they respond, we want that, we want that stimulus to stay up. I'm just trying to build kind of the basic structure. Okay. Clean that up a little bit. Okay, let me just bring those all. Okay, so if I set something like this up, maybe I wanted the image to stay up for 5 seconds, and they can press the button at any time during that 5 seconds. But when they press the button, we don't want it to like change the screen. We want it to stay up for 5 seconds regardless of whether they press a button or not. So in this case, I can change this to 5 seconds, and then basically, let's imagine I left it as it is now. If they press a button 2 seconds after that display, then this would stay up 5 more seconds for a total of 7 seconds, which is not what we want. We want this to stay up for 5 seconds regardless of whether they press a button. And so to make this elapse, like to make this fire 5 seconds after this, we can just link this or reference this to that display screen action. And that way, now, regardless of whether they press a button, that screen's going to stay up for 5 seconds. So you can use the same trick in different ways too. Okay, just wanted to show you that. So let's go back here to the slideshow and move on to our next topic, which is this like somewhat mysterious action that all of our experiment builder examples have that's called a prepare sequence action. Okay, and so I'm going to go out of here for a second. And I'm going to go back to our example that we were just talking about, and simple timing example. If we go to the trial sequence, so if we go to the, sorry, let me go to the very beginning of the experiment. If we look at the trial sequence, you can see this is one that has an iteration count of 4. This is the one that's looping and doing our trials. That's just kind of basic experiment builder programming. And when we go inside that, we'll see that we have a prepare sequence action, and then a drift correct action, and then we start our actual trial events. And so this whole sequence is looping, and the events that are actual like experimental events happen only inside this recording sequence. Okay, and so it's like, all right, why don't I just have this and like skip all this stuff before. Like, why do I even need this extra trial sequence and this recording sequence here, which just has an iteration of 1? And that's because this prepare sequence helps us with some timing issues. So a prepare sequence action in Experiment Builder does a lot of different things. And I'll kind of try and discuss what it does here. Let's go back. The short version of the story is it basically loads this the trial stimuli into the computer's memory before the trial so that the timing is optimized. That's the kind of one of the main things it does. So if you look over here, it's loading the screen resources. That's like images, videos. It's loading any audio. It's also kind of reinitializing the different nodes in your experiment and any video resources and kind of flushing out some kind of logged information. And all these different things that have these checkboxes here, these all help Experiment Builder to optimize the timing of the stimulus presentation. And so all our examples use a prepare sequence. It just helps to make sure timing runs well and basically gets the trial ready to be presented before the trial starts. That's one thing that it does. Another thing that it does is it transfers one of the, so we have a lot of display screen actions inside this recording sequence. This will allow us to transfer the contents of, and by contents I mean images, shapes, whatever is being drawn by a display screen action. It allows us to transfer that to be used as the background on the host PC while we're recording data. Let me just see if I can pull up a little screen capture. I'm just going to pull up the one of our manuals. So, oops, I'll go in here and I'll pull up EyeLink 1000 Plus user manual. Just trying to. Sorry, I thought I could find this faster than it's taken me. There. Okay. So this is what you would see in the host PC, and so basically you'd see like a little gaze cursor like moving around and on top of what they're seeing. This background that has this text here was sent over to the host PC by the prepare sequence action, and so that's another thing that it does. In addition to like loading on the screen resources and audio and stuff, it also transfers that image over to the host PC so that we can see what the subject sees during the trial. Okay, and this, the reason I'm mentioning all this in the context of the timing webinar is that this stuff takes a little bit of time. Okay, so if we go back to our, if we go back to our little PowerPoint, so it's loading the trial stimuli, it's transferring the image to the host PC, and it takes some time. So it actually, we've tested this a lot. So it takes about 300 milliseconds if you're not transferring the image. And so in other words, if your prepare sequence action has draw to EyeLink host turned to no, then this will take about 300 milliseconds. If it has draw to host set to image, it'll take about 500. Okay? And so that means that we're basically adding about 300 to 500 milliseconds, which is not super long, but it is some amount of time. We're adding that amount of time between trials, okay? So that's an important thing to keep in mind when we start talking about inter-trial interval. Okay, and then we're just going to do a drift check, which doesn't really, like, it kind of kills any timing considerations because the drift check depends on the experimenter, like, or the subject like pressing a key to when they're looking at the target or pressing a button on the button box, and so that kind of kills any kind of timing consideration. So if we want to set like a set inter-trial interval, we'll have to get rid of this. But I just wanted to point out that this prepare sequence action is important for timing, but it also has a little bit of a timing cost associated with it. Okay, and so that's what the prepare sequence, we'll come back to that and talk about it in a second. But it's really important to put one of those in there if you want to make sure that timing is optimized in Experiment Builder. Okay, and then the next little topic is use of the is real-time property. Okay, and there's a property on any sequence. So by sequence, I mean one of these like bluish purple rectangle things. So in Experiment Builder, as you all probably know already, like basically you can use sequences like this to control recording of the eye tracker. And so our innermost sequence in all of our Experiment Builder examples is always called recording, and we always have this property called record checked. And when you check record for a sequence, it means when you enter that sequence it'll start recording, when you exit it'll stop recording. Okay. Sequences also contain a property called is real time, and that means that if that's checked, then that means when Experiment Builder enters that sequence, it's going to like elevate the priority of the Experiment Builder application in your computer. So it does that in an effort to kind of like optimize timing. And so basically all applications have like priorities in your operating system, and what we're trying to do is just like raise the priority of this application so as to minimize the possibility of other applications that might be running in the background, basically to minimize the possibility of those other applications interfering with Experiment Builder. And so if you check is real time, then that will help to optimize the timing as well. Okay, so that's the timing, that's is real time property. And so we want to make sure that that's checked. And then the final thing I wanted to go over is like how we can control the inter-trial interval. Okay, and so what I mentioned is that in our example, like this is going to take a certain amount of time, but maybe like in our example, maybe we wanted the time from when the screen is blanked at the end of a given trial until the first display screen action that has actual trial stimulus on the subsequent trial. We want the time between those two events to be some fixed amount. Okay, if we want to do that, then we have to use a little bit of trickery here. Okay, because basically what's going to happen in your experiment is you're going to have your trial sequence that's doing all the looping. You're going to have that looping, And on each loop, it's going to load up the trials stimuli into memory, and it's going to transfer the image to the host PC. Then it's going to do a drift check, and then it's going to come in and do your recording. So first of all, if we wanted to control the timing in between trials, we're going to have to kill this drift check, because that depends on experimenter or participant pressing a key or button. And so that's going to kill our intertrial interval right there. So we would have to get rid of that. But then we would also have to do a little bit of trickery to make sure that our intertrial interval is fixed, okay? And so I actually just took a little example. I took this example from our support forums. I'm going back here. I'll post it on this webinar page. But basically, under Experiment Builder Examples, we have this project that's called setting a fixed intertrial. This example called ITI example that describes how to set a fixed intertrial interval. And so that's the one I have open over here as well. So this is a different project. This is different than the one we've been talking about now, but I have it open just to have it ready. And so let's just look at the basic structure. Okay, this is the experiment. We have a block sequence. In this case, we only have just one iteration of the block sequence. Inside that, we do a drift check at the beginning of the block, and then we start our trial sequence. And so this is going to iterate 6 times, okay? So this is kind of analogous to the trial sequence we saw in the other project. And as I mentioned, inside that trial sequence, we have a prepare sequence, and we would have to kill the drift correct action, because that would disrupt our timing. Okay, and so what we're trying to do is have a fixed amount of time from when the screen is blanked on one trial, like until we come back to the next trial stimulus. So this is where we're presenting the stimulus. We're waiting for a certain amount of time, pressing a button, then we blank the screen, and then we want to have a fixed amount of time before the next trial stimulus. And so I always, when I think about this, for some reason I think about this timer. This is our ITI, intertrial interval timer. This timer is going to kind of like eat, it's going to eat this prepare sequence in a way, so it's going to kind of like subsume, or like this prepare sequence, the entirety of its duration is going to be kind of like contained by this timer in a way. And so first of all, we will have to use an ITI duration that is greater than, if I go back here, 300 milliseconds if we're not transferring the image, or greater than 500 milliseconds if we are transferring the image. Okay? And by transferring the image, again, I mean like in our prepare sequence action, if we're transferring the image here, then our ITI timer must be greater than 500 milliseconds. And if we're not transferring the image, our ITI timer has to be greater than 300 milliseconds. Okay, and I would actually say greater than 600 and greater than 400 to be safe. Okay, and so if we go in here, it looks a little bit complicated, but it's really not that complicated. What we're doing is at the beginning of the trial sequence, or sorry, of the recording sequence, we're using a conditional trigger, which is like an if-then statement, and we're checking to see if the trial's iteration is 1. And so basically what we want to do is check to see if we're in the first trial or not. If we're in the first trial, then there is no intertrial interval to wait yet, because we're not between trials, we're before trials, right? And so on the first trial, we just want to go ahead and present the stimulus, okay? And so let's just start with the case of the first trial. In the case of the first trial, we're going to come down here, we're going to hit this guy. Okay, it's trial number 1. We're going to draw the stimulus. Then we're going to wait for either 4 seconds to elapse, or for the participant to press a button, and then we're going to clear out the screen. Okay. Then we want the time between this screen clearing and the time of the next trial stimulus to be 1 second exactly. If I look at the duration of this timer trigger, it's 1 second. So what we're going to do here is have a little variable here called last trial time. And after that blank screen happens, we can use one of these update attribute actions to say, okay, last trial time is going to be equal to the time of that blank screen. Okay? It's kind of the same trick we used at the beginning of this or earlier in this webinar. And so we're storing the time when this blank screen occurs. Okay, and then since there's nothing after this, we're going to exit this sequence and come back and do we're going to do the prepare sequence for the next trial. So we're kind of back in our loop here. We exited the recording sequence. We set the value of that variable, exited the recording sequence, and then came back here and then loaded up the next trial, which is going to take about 500 milliseconds. And then we're coming in here again, and this is going to check, are we in trial number 1? And this time, no, we're not in trial number 1. And so we're going to follow the little X mark path over here and go to this ITI timer. And you can see it has a duration of 1,000, but you can see we're using that same trick where now the start time is not fixed at 0, which would be like 0 milliseconds from the start thing, which would actually end up being about 1,500 milliseconds from the blank screen because of our prepare sequence action. And so what I'm saying is we're trying to like eat that prepare sequence action by this. And so basically this timer is going to kind of include that duration, that prepare sequence action, because its start time is going to be linked to the time of the blank screen from the previous trial, because we're referencing that variable which is storing the time of that blank screen from the previous trial. And so since it's 1 second since that, then the time from the previous trial's blank screen action to the current trial's display stimulus will be 1 second exactly. And it should be down like, you know, to the millisecond really if everything's set up correctly as we've done here. And when you check the times in the data file, you should see these things should be down to the millisecond. And so that's how you can implement. I know it kind of like looks a little bit intimidating at first, but it's actually pretty simple. Like basically that's how you can implement a fixed interval for your intertrial interval. And if you wanted this to be if you wanted this timer to have a different value for each trial, you could have something like a data source column that could be like ITI duration, and maybe we can make it a number, for example, and then we could do 1,000, 2,000, 3,000, something like that. And then this way we could have this timer, its duration property linked to that data source column, and that way we could change the intertrial interval if we wanted it to change. But the general idea is the same. We're basically having a timer whose duration property is set to some value, but whose start time is linked to the time of the previous trial's blank screen. And so that's what that's the little trick we can use for controlling the intertrial interval. And so basically, what I tried to do was just cover like the tricks that are commonly used to control timing in Experiment Builder, and I just wanted to talk about like some of the considerations, and that's really all I wanted to present today. So I'll just give a couple minutes. If anybody has any questions, I'll just wait to see if anybody has any questions. Otherwise, that's it for the webinar, and thanks a lot for attending. But anyways, any questions? If you have a question, you can like chat it out. Okay. So it sounds like we don't have any questions. So thanks a lot for attending. And if you want to attend future webinars, just keep a lookout in our webinars section of our support forums. And we announce them in here ahead of time, and you can check it out here. You can subscribe to the forum if you wanted to get a notice of it, but basically we'll do more and more webinars. And if you have topics that you would like to cover for a particular webinar, do not hesitate to let us know. Like we want to make these things constructive to users, and so like if you got ideas, let us know. So anyways, thanks a lot for attending, and see you next time.